Hello, welcome to Plutus IAS. So today we are going to discuss about the matrix minima. That means to find the initial feasible solution in a transportation problem by matrix minima. We have already discussed about the northwest corner rule to find the initial feasible solution in a transportation problem. And now today we are going to discuss about the matrix minima. That is the matrix minima method to find the initial feasible solution only, initial feasible solution in a transportation problem. So name itself clear that the matrix minima, as in case of the northwest corner rule, we start from the northwest corner. In case of matrix minima, find the minimum element in the matrix. So here that are the supply S1, S2, S3 at S1 15 unit, 25 and 20 unit. Similarly at demand 10, 15, 25 and 10. Obviously you can check the TP balance, that is 15 that plus 25 plus 20, 60, and here again 25, 25 and 60. So now in matrix minima, first step to find the minimum cost. Minimum cost, that is the, we know that these are the costs C11, C12 and so on are the cost. So first find the which one is the minimum in matrix. So here 1 is the minimum, so allocate as much as possible. So your demand is the 15 and availability is 25. So obviously this cell can get the 25 unit. So now 25, so he can get the 15 units. Now that is cancel out, that is complete now. And now update, so we'll get the here cancel out. So here 10 update and 25 and then 10, and here we'll get the 10 and then 15 and then 20. So now again after the cancel out, we have the 1, 2, 3 column, and now again the remain matrix, find which one is the minimum. So which one is the minimum element in remain? So you can see that the 2 is the minimum. So after deciding the cell, allocate as much as possible here. So your demand is the 10 unit, and you can see demand is 10 and supply is 10. So now we can uh, give this cell to 10. Obviously we can give 10. So after 10, so that is the 25 is cancel out, and here also this one is the cancel out. So this is cancel out also. So now update, rest part update. So here that means the 25 and here 10 and here 20 remain and here 15 remain. So after these two cancel out and one is cancel out, we have the these four remain. So these four remain. Which one is the again minimum in this four? This one is cancel out. These two cancel out. So these four cells are remain. So in this four cell, which one is the minimum? 3 is the minimum. So allocate as much as possible again. So 10 is demand and supply is obviously 20. So obviously this cell can get the 10 unit. 3 is the minimum, 3, 7, 59, that 3 is the minimum, get the 10. So this one again cancel out. So cancel out, update. Yeah, the 25 and that is the 10 unit. So that is cancel out and 15 unit. So this one is also cancel out. So now what is the remain now? So obviously here the 15 and 7 only remain out. These two cancel, and this cancel. So only 15 and 7, these two cell are remain in this cell. Again find which one is the minimum. So 7 is minimum. So allocate this cell as much as possible. So obviously your demand is 25, your supply is 10. So we can allocate it. Which color can we choose now? Okay. Okay. So allocate it the 10. And now here then rest only the 15. So now this cell can get the 15 unit. So now you can check by row wise. 15 done, 10 plus 15 25 done, and here 10 plus 10 20 done. In this column wise 10, 15 and 15 plus 10 25 and 10. So everything is now fine. 1 2 3 4 5, 1 2 3 4 5, and we need actually 1 2 3 4 and 1 2 3 7. That means 4 plus 3 minus 1, that means 6. But here we are getting the 5 solution, that is the degenerate feasible solution. So that is the initial feasible solution in a transportation problem. What is the solution? That means solution is actually x11, x31. So we can write the solution here. What the solution we have? like x3 1 equal to 15, okay, x21 equal to 10, x22 equal to 15, and x33 equal to 10, x34 equal to 10. So these are the solution, and cost in this case, cost will be 15 into 15 plus 2 into 10 plus 1 into 15 plus 7 into 10 and plus 10. You can get the whatever the problem, that is minimum value, minimum of objective function. So these are the method of matrix minima, that means to find the initial feasible solution in a transportation problem by matrix minima. So one more method is remain, that is very important, called the Ozel's approximation method. So in upcoming video, next video, we will talk about the Ozel's approximation method to find the initial feasible solution.